Balancing equations. We're going to look at balancing equations of several different kinds, and we'll start off with some combustion ones because they're way cool. No matter how hard it is, you're not this guy. Failure won't kill. You can read this yourself. We just got to get clear about what bonding is. Bonding is a welding together of atoms through either a donation bond, ionic, or a covalent bond, sharing. The valence shells determine this. You don't get to decide to make MgCl3 any more than you could decide to plug this into there. It can't be done. So step one, you get your formulas. You cannot construct MgCl3. You are forced to construct MgCl2. But when we go to use them, you may find you don't get these quantities to add up when you start mixing them. So the quantity is shown by large numbers in front. It doesn't indicate bonding, but consider it to be scoops of chemical. Two fluorine atoms will mate in a covalent bond, so they are called F2. But two potassiums are just going to hang out together. They're not going to do any sort of bonding because each one's going, you take it, no, you take it, no, you take it, no, you take it. There's no bonding there. They just hanging out together. So, hey, I've seen two potassiums. This is like saying, I saw a pair of pants. They're attached. Two chlorine atoms put together make Cl2. A pair of chlorines put together would be 2Cl2. Again, sounds complicated till you think of pants. This is a pair of pants. They're joined at the crotch. Here's another pair of pants. They're joined at the crotch. The two pants are not attached to each other. So it's two pair of pants. 2Cl2 is two pairs of chlorine. You can read this as two scoops of chlorine molecules. You don't write Cl4 because that would be like a single pant with four legs, something weird like this. It's like some sort of modern art statement about like the British involvement in the Falklands or something. No, one pair of pants doesn't have four legs. This is two pair of pants, two pair of chlorines. Now, once we make a molecule, it's not tamperable with. And this is something that is a great problem with a lot of students. They just want to disassemble the molecule when they need the parts. So the best example I can think of is Halloween loot bags. Your mom wants to make salty candy, nuts and almonds, and peanut bags. So she decides in the infinite mom wisdom that it was intended that Halloween loot bags contain 2 salty candies, 1 nut and almond bar, and 5 peanuts per bag. And this is her loot bag, and this would be the formula. Sa2NaP5. I just hate those peanuts. They're just way too happy. So here's the complete loot bag. Now, you decide to pester your mother slightly before Halloween. But Mom, I want 3 nut and almond bars. Would you open 3 bags and take out the nut and almond bar from each bag? Do you feel lucky, punk? Mothers have killed for less. This is the package that is delivered. You don't tamper with the inside once the package is put together. You must take 3 loot bags if you want 3 nut and almond bars. The formula Sa2NaP5 was determined by your mother and you cannot change it now. So this is what you need to do if you want 3 nut and almond bars. You take 3 packages. And you're gonna, but I don't want the salty thing in the peanuts, and stick them in your ears. If you cut open 3 of her loot bags and take out the nut and almond bar, you might as well leave the continent. And the worst part is, if you're allowed to get away with breaking open the loot bags as a kid, this is what happens to you as an adult. This is a faucet cartridge, and it's one of the things that dads get to repair once in a while. The faucet breaks, you go to a hardware store, and you buy a new cartridge, and it comes with all these parts in the package. It's a package. It comes together. You need all the parts when you buy the parts in a package. But some of you go out there and decide, well, I was installing a new cartridge and I lost the washer. I don't want to buy a new cartridge, and I am certainly not a thief, so I'll just go to Canadian Tire, peel open a package, and take the O-ring out that I happen to need. And then I show up and I buy the thing, and I get it home, and I find out there is no O-ring. And you've gone home thinking, I'm not a thief. I just took the O-ring. Well, you might as well have taken the whole package because it's not a cartridge anymore. You took out a part. Right? Try taking a part off your dog and see how well it functions. My sister used to do this. I'd make a clubhouse sandwich, turn my back, she'd take the bacon out of it. The bacon defined it as a clubhouse. It's a chicken sandwich now. Leave the small numbers alone. Okay, now we're back to chemistry. Sodium meets chlorine. Chlorine will always go out together as twins. It's one of the halogens. They're like creepy twins from a movie. Come play with us, Danny. And so this is chlorina and chloretta. Now, the bonding rules say that when chlorina and chloretta meet sodium, only one of them can bond to the sodium. So what we have here is a single sodium metal atom because they don't bond to themselves. The pair of chlorines going, come play with us. And a happy marriage takes place on the right. But hold on a moment. Chloretta, she's vanished. Ew, search quickly. Bang the shrubbery. Where is Chloretta? Oh, there she is. But my dear, she's crying. Oh, whatever could be wrong, Chloretta? Am I to be lonely my whole life? Is there no one for me? And will I go? Dear, if only there was another. Oh, wait a minute. He has a brother. Yes. Oh, my second child. She's happy now. See? If we bring in a second sodium, we can marry off that other chlorine. Otherwise, she's going to go on a vicious rampage, peeling the paint off the walls and doing all the things that solitary chlorines do when they're by themselves. So when we put it all together, this is what we needed to do. We needed 2 scoops of sodium, and a single pair of chlorine atoms would allow us to construct 2 salts, 2 sodium chlorides, with nothing left over, because you really don't want, if you ever seen horror movies, there's twin sisters and one of them doesn't get happiness and the other one does. It's really bad. So now all the ingredients have been used up. Let's try another one. We're going to set fire to iron. Yes, that's what rust is. Iron oxide. I am telling you to use iron in the +3 valence. And oxygen is always in -2, and we're going to make iron oxide. So you have to figure that one out. So you get out your trusty little drawing kit and you make yourself the Lewis dot diagram. And you quickly realize that it's 2 irons can park their electrons and 3 oxygens orbit. Those of you that paid attention to other lessons have now done the crossover method and you just immediately leap to the formula for iron oxide. So we're dealing with this. Iron plus oxygen will make Fe2O3. The packages are sealed. You don't play with these little numbers now. This is the only way this can be assembled. But we have a parts mismatch. Now we tackle the scoops. Okay? We don't touch the little numbers anymore. You don't open the cartridge package. So what do we have to do here? Well, let's look at it. 1 iron, a pair of oxygens, and this little fidget spinner here. Do you see the problem? 2 and a 3. They're not lining up too well. We got a package of 2s and we need to use 3 at a time. But when do 2 and 3 land on the same number again? Why, it's 6. 3 pairs, 2 triples, and la-la, there it is. We've balanced this part. Hold on a moment. You only have 1 iron and you needed 4. Well, there we go. We add the 4 irons we need now, and bingo, it's done. We've balanced it. 4 iron atoms and 3 pairs of oxygen can make 2 fidget spinners. And it's balanced. And it's rust. It would look like this. Okay? So there you go. You've made some rust properly. And we'll take a pause and come right back to the next program.